Well, hey everyone, and welcome back. We're continuing this video with isostasy, and with this one I'd like to begin with a riddle. This was taken from J.R.R. Tolkien's The Hobbit, and it's from chapter 5. Some of you might recognize this, but the riddle goes, "What has roots as nobody sees, is taller than trees, up, up, up it goes, and yet never grows." Okay, so the answer to this one actually is mountains, which is pretty interesting. I actually didn't think of this until I read the book again just recently, but it's actually a reference there to the geologic concept of isostasy. The line I'm particularly referring to is "what has roots as nobody sees," which it's kind of strange when you think about it. Mountains having roots, how does that make sense? They're not like trees, or are they? And that's what this video is going to be looking at, what actually goes on with a mountain. So when we think about an orogenic belt, right, a convergent plate boundary between two continental plates, right? Let's say we've got a plate here, right, just sitting there, and we'll just draw it flat for the sake of keeping things simple. And this one is, we'll say, mostly staying stationary. But then we've got this one off to the other side, and it is moving to the left. It is moving towards this plate, right? So let's just say that if we were to, just for the sake of example, if we were to take this little section of the plate here, and we were to give it a mass, we'll represent that with m, right? There's this amount of lithosphere, and the mass of that amount is represented by m. So what we see as this plate moves to the left is that it'll eventually overlap, right? That's what continental convergent boundaries do. The continents completely overlap and they superimpose each other. So what we're going to see is that, if I can grab my eraser, what we're going to see is that this is going to superimpose the other one, and we'll say it's moved such that the plate is now like this, right? It is overlapping completely at the point M. Okay, so if these are two continental plates, then the density is going to be about the same. So if the volume is roughly equal, then we can say that now contained in this specific spot, there's actually 2m, twice as much mass. And of course, since mass is the force of gravity, the more mass you have, the more force you're going to apply down on the Earth. What this also means is that there's going to be a greater downward force, twice as much force applied downwards. So also I'll draw this in here. When the two plates superimpose, right, they fold upwards. That's what creates a mountain. So I'll just draw a triangular mountain to represent this here. Obviously, mountains don't work that nicely in real life. But we've had two plates that superimpose, and they formed this mountain. But then the final thing to consider is that since this is now at 2m, it's twice as much mass, there's twice as much force being applied down onto the Earth. What we're actually going to see is that the asthenosphere is going to react to that, and it's going to dip downwards. All right, so these plates are going to move, just sort of, dip downwards. That's a pretty bad drawing. Let me try. It's going to look something like this, right? Maybe that goes like that. Just around this little mountain. So as these two plates have superimposed, we've actually not only created a mountain going upwards, but the increase in mass that comes with superimposing two plates over the same area, that's actually going to cause the asthenosphere to dip inwards and the lithosphere in response to move down. So now you know what that riddle meant by mountains have roots that nobody sees. Stay tuned for more videos on isostasy. I will be doing at least a couple more just to clarify a few more things about the specifics But hopefully this video itself was informative, otherwise good review. Hope you guys enjoyed, and I will see you all in the next video. Ciao.